Hello, good morning. This is going to be calculus, and we're going to be using chain rule to look at some trigonometric functions and how to use the chain rule and find the derivative of these trigonometric functions. So today we're going to take the derivative of 2CSC squared pi k minus 3. So this k right here is just a variable like x. I chose to use k in this example. Okay, so first off, we're going to look at the different transcendental functions with the chain rule. You'll need to know that before you get started. And chain rule is used for composite functions. So with the transcendental functions, with the chain rule, we have d over dx. Then first one, these are just the trigonometric functions. Sine u, and then so that's equal to cos u prime. U is just whatever you're taking the sine of. Okay, so we could do this for 5 other ones. There's 6 in total. So cos u is equal to negative sine u prime. We have tan u, which is equal to secant squared u times u. Now we have CSCU. This is the one we're going to be using. So negative CSCU cotangent u prime. We also have secant u equal to secant u tan u prime. And then we also have cotangent u is equal to negative CSC squared u of u prime. And also we have the e to the u power, which we won't be using here, but it's one of the transcendentals. So we have eu u prime. Okay, so now back to our 2CSC squared pi k third function we're going to find the derivative of. Looking at this first glance, you might think that this is one number and then this one. So you're going to think that these are two separate numbers, so you could like split them apart and do the product rule. That is not the case. This is actually what you're taking the CSC of. So it's actually, this is one number, and then this is the 2, which is standalone number. Okay, so first we're going to get started by using the general power rule, which is u to the n, which is equal to n minus 1 u prime. Okay, so now we have the general power rule. Now we could use it, apply it. We're going to ignore that 2 in front for our first step. Going to take the CSC squared, going to bring down that 2 exponent, so we get 2CSC to the first now. Because of the n minus 1, we took n minus 1. N was equal to 2, so then that equals 1. Then we're taking the pi k 3. Okay, so that's that first part. This is the nu. Okay, so now the u part, u prime, will be this negative CSC u cotangent u prime. So now we need to work that out with our u's that we have. So how we're going to do that is we're going to take that negative CSC, our u is pi k minus 3, and that's multiplied by cotangent pi k minus 3. And then we also have the u prime, which is also the pi that we have left over, the pi k minus 3. Derivative of that is pi. I'm just going to write that out. Derivative of pi k minus 3. Since we used the power rule here, that's just a constant or variable. So then the derivative equals pi. We're going to put that one right at the end there. And we're going to also have that 2 still in front from earlier. Okay, so that was with the general power rule. So we have 2CSC. You don't really have to write that 1, but since we did n minus 1 and n equaled 2, you could write it there. So pi k minus 3, and then here's the u prime, which is the derivative of the cosecant, and then with our u, and then we'll also have that derivative of inside of here. So now we're going to just combine some like terms. For first, we're going to multiply the 2 and the 2 to get 4CSC pi k minus 3 minus CSC pi k minus 3 cotangent pi k minus 3, and then we still have that pi at the end. Okay, so now we're going to actually combine like terms or simplify. Okay, so we're going to see here we have a CSC and another CSC here, and then there's a negative. So we could bring that negative up in front if we move these terms around. Could put -4, but we also have this pi in the back that's being multiplied this whole thing. So then it'd be 4 pi CSC, and now we have these two CSCs, so they're multiplied, so CSC squared pi k minus 3, and then we have that cotangent, which we can't really do anything with, cotangent pi k minus 3. And that's our final answer for the derivative of 2CSC squared pi k minus 3. So in review, we looked at the transcendental functions with the chain rule. So these were here. We also were going to use the general power rule. We needed specifically from up here the CSC U1 because we're doing a function with CSC. Then we used the general power rule and actually applied it to the CSC squared pi k minus 3. And so we brought down the exponent, -1, becomes the new exponent at that part. Now we take the u prime, which is CSC pi k over 3, cotangent pi k over 3, which is from here. And we also have the u prime, the derivative of pi k minus 3 is equal to pi, so we put that in the box. Now we took 2 from earlier that we were ignoring, but now we brought it back and multiply it. So now for CSC pi k 3, negative CSC pi k of 3, cotangent pi k of 3 with the pi. Now we could even multiply here, and then we also have the two CSCs. One of them is a negative, we're multiplying them, so -4 pi CSC squared pi k of 3. We can't really do anything with that cotangent there, so then we're just going to leave that as cotangent pi k over 3, and now it's the derivative of 2 CSC squared pi k of 3. And in conclusion, when using the chain rule to find the ones in trigonometric, going to want to use the power rule, and especially one of these transcendental functions with the chain rule. You're going to do some simplifying, combining like terms, and then you'll get your final answer. Thank you.